intro done. If you needed a refresher, you missed the Jeopardy day. It was basically, you'll be given some type of constraints. So say if it was that fence problem, you're told how much fence that you have available. You're told the shape of whatever you're trying to enclose, and then you want to know, how do I maximize this area with this much material? Okay, so all you have to do to maximize anything, to find a maximum, you get a derivative, you see where it's equal to, where it equals 0 or where it's undefined. You see where the derivative was increasing then decreasing, and then you find a max. Okay, so this is just the thing that you have to do here is come up with a function yourself, just like with related rates. Like, oh, geez, what's my function? Is it a proportion from similar triangles? Is it going to be, what else? There are all kinds of things. Pythagorean theorem, trig function, geometry formula. Same stuff here. Okay, again, here's some examples. You might want to minimize cost, maximize profits, maximize an area, minimize material. And so whenever you do solve these problems, please remember one of the very last steps is verifying that you did find what you're supposed to. If it asks you to minimize something, I want to see some sign chart, some number line, something showing me that the function did decrease and increase, so you really did minimize it. Because 1 out of 50 times, if it tells you to minimize something and you find the critical value and you give your answer, you actually found the maximum instead of the minimum. Okay? Usually it's just going to fall into place and you're going to find what they're asking you to find. But once in a while, you're going to find the opposite thing, and then we have to come up with a new plan.
Well, good, then it'll be good. Then we are taping this for Veronica and Kelly and Alec. He might look like he's here.
Yes.
He's not really. There we go.
I was like, what are you doing? I forgot to
I wanted to keep
Yeah.
my,
I'm being really lazy. I'm good at it. Okay. Do you think that you can draw a picture? Okay. So how do we indicate that that was a square base? When I label it with variables.
They're all equal for x.
The same variable.
Right.
Same
Okay. Does the height also have to be x?
No.
No. So give me another letter.
L. Y.
Okay, I would have loved y or h. Yeah, L. Not. I mean, L's fine, but L's not usually the height.
What's the L?
Get the L out of it.
Okay, so we need to find the dimensions of the box that minimize the amount of material used. So we are trying to minimize what? Like, give me a geometry term. What?
Surface area.
Yay. Okay, so we're trying to minimize surface area. So let's write an equation for surface area. And this is the one we're going to eventually be differentiating. How many sides is this? Good. Awesome. Okay, that's... Yay. Right. There's the bottom. So there's the 4 sides, there's the bottom. Okay, let's look at the steps. This is really, really similar to related rates. We drew the picture, we labeled it with variables, we figured out what variables to be optimized, we wrote an equation involving that variable. Now, with the given information that we didn't use yet, we can make another equation. And then that'll let us get rid of one of these. Get the something out. Maybe that's why you said L, because then we could have gotten the L out of this one. But we're probably going to be getting an H out is probably going to be the easier, but maybe X, who knows. All right, so how do we use the 32,000? Good. So 32,000 equals the volume, and it, awesome. Now you want to choose the easier variable to solve for, which would H. Okay. Okay, so now your surface area is 4x h. Con would have switched colors for this, by the way. Right here. And before I differentiate it, I want to simplify just a little bit. Times 32, 64, 128. guess why I made the page just a little bit bigger. Okay, so if we're trying to maximize surface area, what do we have to do with the surface area equation now? Yep. And we don't have to do the differentiate with respect to time this time because the box is the box. Like, it's not changing, right? You just want to know what's the derivative of surface area with respect to the side length, x. So we're not differentiating with respect to time, so we're just going to say SA prime and just take the derivative with respect to x. So think of this as 128,000 x to the negative first, right? Okay. Hi. What's up? So what's the derivative of 128,000 x to the negative first?
28,000 over x squared.
Yes, negative 128,000 x to the negative second, I heard somebody say, so yes, Logan's good. And then the derivative of x squared, 2x. All right, so when you want to get your critical numbers, yeah, set it equal to 0. Now,
What's
you
this
also want to
column
make it,
ask for?
it wanted to know,
Minimum amount of material.
Yeah.
It said surface.
yeah,
So
what's
the
it,
smallest surface area
minimize the
possible.
amount of material.
Okay.
Same thing.
So what I do want to do is get a common denominator. Okay.
I guess.
So that now I can, to find my critical numbers, set the top equal to 0 and set the bottom equal to 0. Okay. All right, so on the top, I'm going to swing the 128 over to the other side, 128,000.
64,000. So what is that? 8,000? 800.
Well, but that's x cubed.
Oh. 2,000.
4.
4.
And then think about, I'm cube rooting of
I can't.
I'm
400.
40. Yeah,
Something like that.
that's an x. So x is 40, or from the denominator, x is 0. Think about the domain of the problem when you're doing this. Should, yeah, perfect, good. Okay, or you wouldn't have a shape to begin with. Okay, so we're just not even going to think about that part. So we just need between 0 and 40, and from 40 on. So let's pick like a 1.
We can have like
Right.
antimatter. That's not.
So negative 128,000 plus 2. Okay, and if we put in 100, you're going to get,
A positive number.
so you did indeed find a minimum, and that's all you had to check. All right, so we found our answer. You're going to minimize the amount of material necessary when x is 40. And I don't remember the units. Were they meters, feet?
Cubic centimeters.
Oh, okay. Okay, so this is 40 centimeters. You can give the answer this way. You can label it on your picture, or you could go 40 by 40 by something. We still have to come up with that something. How do you do that?
Plug it in.
Mm-hmm. Okay, so it's 32,000 over x squared.
20.
Yes, sir.
I think your picture is actually pretty proportional too.
Yeah.
Wow.
This is a good day. We're going to go. Thank you and good night.
What?
I don't know. It's kind of a Seinfeld